Good morning. Welcome to episode number 52 of the ZOOMTOWN experiment. Today we're going to take a little sidetrack adventure here and talk about debugging. One of the problems I've had with the Zoomy since the very beginning when we started testing out here in the actual ZOOMTOWN arena was this random freeze up of the Zoomy. And this particular Zoomy here is one that's fully optioned up, and it's one that I've been using in this debugging process and developmental process. In fact, it was getting to the point where I was doing just about everything I can, including adding a voltmeter on the Zoomy so I could monitor voltages. But while the Zoomy was on the field, the front and back LEDs were always blinking, and that was a tool that I used to help me observe behaviors throughout all the testing and so forth. And when it would stop blinking, I knew the PICO had froze up. Now I had swapped out different PICOs, messed with the power supply, ran from a bench power supply for a while, did all kinds of things, and never got to the root of it. So a few weeks back, I really committed myself to tracking that down, because it's getting to the point where things are getting to where I need to be able to trust this thing to run all the time. So what I ended up doing, I would just put it on the bench, let it run until it would freeze, and observe about when it happened, and then look at different variables, etc., to try to understand what's happening, what's causing it. It was completely random. It would the Zoomy could run for 10 minutes, 20 minutes, 30 minutes. It had nothing to do with how long. I checked all the memory, no memory leaks, all the typical problems. And then, of course, you got to blame hardware. That's a software guy's approach to getting out of doing something, and that led to checking voltages and that sort of thing, and shorts as well. Nothing. So then it came down to process of elimination in my code. Now we'll take a quick look at that here. This is one of the more recent versions before the big change, and that's the subject of another video coming up. But we've got a number of libraries that we're importing. Some of them are built-in libraries, some are external libraries. I don't know how they're running. I never really monitor them. I just trust that they work. We got all the networking. That could be a problem. We could be having trouble with Wi-Fi. I've got MQTT going. That's running in the background. Could be having a problem with that. But there's the MQTT stuff. We got a lot of hardware that we're utilizing. I2C, that can be interesting, because if an I2C interface drops out because I didn't put pull-up resistors in the circuit, that kind of left me in a, we'll call it a iffy situation. So I had to do monitoring of that. Then we get through a lot of use of global variables, and those can always be a problem. But then I get into the code here, and we're doing a lot of this stuff. It's being called up automatically, and then it'll run for a couple milliseconds. Then we go to another section of code. Very typical of a Python or MicroPython program. But there's so many different things with a fair amount of math calculations in there and dependency on other functions to behave properly. It was anyone's guess what was causing this issue. So my approach, as I was getting through it, now I'm almost to the bottom of the code. Okay, that's the very bottom, our main loop. But my approach was this then. I eliminated all the ones that I felt could be causing it based on what I'm seeing. And that was the power, short circuits, loose connections, that sort of thing. Didn't exist there. So now you got to whittle down, start taking out something, and see what the behavior is. Does it change? Well, if it can run 30 minutes, maybe even more, I don't know. It seemed to always be less than 30 minutes. If it ran that long, did I find the problem? But each test takes that long. And when you're going through a process of elimination of probably 40, 50 items, this debugging process took forever. And I really wanted to narrow it down to the single thing, not just disable half the code and then see if the problem went away. I wanted to go step by step, very methodically, to understand where it was. So throughout this whole program of, we'll call it 1,372 lines of code, I boiled it down to a problem in our main loop. My very specific desire of how that main loop would run, I wanted a deterministic loop. And the problem was in there. Now, I'm going to, let's go ahead and I will run our first test. I'll demonstrate that. I won't have you watch the whole thing. I'll fast forward through the middle. But what we'll do is we'll run this code, which really you'll see I got some silly stuff in here to waste time, just so I'm doing something in that main loop besides getting the current time, starting the main loop start time, checking how long it took, and then down here I'm just going through and printing out some counters so I can monitor its runtime. Well, let's go ahead and run this, and it'll only take a short while before it bombs out, so we'll run it. And as you can see, I got a clock on there so I can determine when it quit. I can always call it back up in video. And down below in the shell, you're seeing the counter just continually going along so that we know it's progressing. The program is running until we get to the point where then it stops moving there, and then we see the time, how long it took to fail. Now that particular test I ran just dozens of times to see if there was any pattern, anything like that, and there was really nothing there. What could it be? Now, as you know, if you've been watching this series, a lot of this code is approaching about a year old. I would build this little module, this one, this one, this one, and this one. This whole thing came about as I had time available. I still work full-time most of the time, so I only get a time here and there to work on this. So I'm away from it, come back to it, have to figure out what I left off with and continue. And I made a very big mistake. And I'm going to show you this code. Let me zoom it up. I'll just let you look at that. I'll put on a little music, give a look at it for a couple of, we'll put it up 10 seconds, see if you can find what I'm doing wrong. Okay, did you see anything there? A sharp eye would have caught it real quick. I'm going to go back to my test program, the one that we just saw run, and I'm going to shrink this back down a little bit. Hopefully you'll kind of see it. In this area, this is pretty much the same code we were just looking at in the full program. And it's to do with this area right here. Okay. See it yet? Maybe not. Let me shrink it down again. Oh, I'm going to comment this one out. That'll make sense here in a moment. Comment out. And then I'm going to uncomment this one. And we'll zoom it up. See anything I'm doing different there? If you haven't noticed it, I'm using TICS diff to determine the difference in time between my 2 points of reference, a start time and then a time or a duration, point in time of duration that I'm trying to measure. I use TICS diff there, and that made all the difference in the world. Whereas earlier, I was using basic math, take one time minus the other time, and work with that. but it worked. I'm not defending my stupidity here, okay, but it did work, and it worked very well. And as soon as I spotted this, I recalled early on when I started playing around with the microcontrollers, reading through the documentation for it. So let me call that up. And let's see, yes, I can zoom that up. Now, in the documents, the library time talks about different functions, make time, sleep we use all the time, sleep MS, sleep microseconds, etc. But where I'm at, we're into the very fine granular periods of time, microseconds, and there are functions that you can do to add time, subtract time, do computations on this time function. But the one, and I got to find it again, so bear with me, time ticks difference. Measures ticks difference between values returned from one of the tick functions as a signed value which may wrap around. That's what I recalled reading and ignored my own research, so to speak. So if I go back to here, you will see here, now this is out of the original code, I'm measuring the time of my entire main loop, and that's these calculations here, and I call that time runtime. Notice it's using math, not the diff function. And then time went on. That was when I first built the whole framework for it. Then as time went on, apparently that part of memory came back alive, and then I started using ticks difference for the time duration, the delta times for each of these functions. Yeah, pretty stupid, huh? But it does showcase problems with programming where if you can't stick to it, time passes, you come back to it, and you would have a completely different approach, only to really mess you up over the course of almost a whole year now that this has actually been lurking there. So I thought I'd share that with you, and I'll go ahead and run this code here, and we'll let that run for literally an hour. I've actually done 2.5 to almost 3 hour runs with the modifications of getting rid of basic math and just using the diff function, which is part of the time module. We'll let that go ahead run here. Starts out just like the other one, ticks away, all that fun stuff, and then I'll go through and fast forward for about 55 minutes. In our time here on camera, it'll only take, I think I got it down to, I'll get it down to about a minute if I speed it up as fast as I think I can go. But once it gets to that point where some rollover event happens in the background, diff can deal with it. Basic math cannot deal with it. And that was what I assume was causing the problem, because that was the one major differential between the two ways of doing this, was that wraparound. And it would make sense in the variable time it takes to fail behavior, because depending on when I start within that, we'll call it the 0 point to rollover point, I could start into that at any random point, which would then determine the duration before the bug hits and crashes and freezes the system. So now you can see it ran, I stopped this particular test for the camera at exactly an hour, and we let it go a few seconds more, and it was still counting numbers down there in the shell, and it didn't freeze up. So with that, I just wanted to go through and share with you some of the complexities of dealing with, we'll call them a large-scale program. For a microcontroller, this is kind of big in some regards, but it's complicated from my perspective in that it's spread out over a year and a quarter, I think now, of all the different time I've spent developing the code and putting it all together. So that set me back a lot of time, folks. There were other things that I discovered with my latest round of testing over in ZOOMTOWN, with the scheduler sending the Zoomie out on its own journeys and all that sort of thing. Discovered a lot of other issues that came up. So the next video I'm going to come out with, hopefully be within a week, it might be 2 weeks out, I'm going to do another status update and explain to you some discoveries that were made and some reasonable assumptions on how to fix it. And then that'll set the stage for a few more videos to get back on track so that we can continue with full trip plan development and testing and all that, and get this thing ready so we can start running some experiments. A couple of old things are coming back into play, a couple of new things are coming into play, and the program, what I'm calling the Zoomie control program, which is what we generally do here for the Zoomie and what runs the Zoomie, you're going to see a very big change in that in the coming weeks. So I'm going to wrap this video up. Thanks for watching, and I look forward to seeing you in the next video, which should be episode number 53. See you then. Take care.